Now taking a look at the last example, asks what is the percent yield of precipitate if a solution containing 33.4 grams of sodium phosphate produced 19.6 grams of precipitate when it reacted with excess aluminum chloride in solution. Once again, we have to write our balanced equation, and so we have sodium phosphate reacting with excess aluminum chloride. And this is going to produce a precipitate, but that's all it tells us. And so let's take a look at our two compounds. We have an ionic compound here, as well as this aluminum chloride. Both of them are ionic. So that leads us to believe that this would be a double replacement reaction once again, meaning sodium will replace aluminum, and aluminum will replace sodium. So let's rewrite those compounds using correct oxidation numbers. So we have sodium chloride plus aluminum phosphate. So here it tells us that we are looking at the precipitate. So that means we have to identify which one is the precipitate, which one is insoluble, and then which one is soluble in solution. And so we know that salt, and if you look at your solubility chart on the back of your periodic table, you would see that this one is soluble, meaning this would be our aqueous solution. And now if you look at aluminum phosphate and compare that to the rules found on your solubility chart, you should see that the combination of phosphate with aluminum is insoluble, and so we would call this a solid or a precipitate. And now we need to balance the equation. So looking here, I think this is all we need. And now we are ready to look back at the problem. We have 33.4 grams of sodium phosphate, and when it reacts with excess aluminum chloride, and so this problem tells us right here, this is excess, this would be our limiting reactant. When it reacts with this excess, it's going to produce our precipitate to an actual yield, our lab value, of 19.6 grams. So this is our actual yield, what we would have calculated in lab. So we need to find the theoretical yield using stoichiometry. And so let's set up our stoichiometry problem. We're starting once again with grams, and so this is going to be that same procedure, that step-by-step process that we've used twice previously now. We are given 33.4 grams of sodium phosphate. So we need to convert grams to moles, so we're going to use molar mass, and sodium phosphate's molar mass has been calculated to be 163 grams of sodium phosphate per 1 mole sodium phosphate. Once again, that's the molar mass that I have calculated. Now we need to use the mole ratio, and remember the mole ratio is coming from the balanced equation. We're comparing moles of sodium phosphate to moles of aluminum phosphate. So you have 1 mole of sodium phosphate to every 1 mole of aluminum phosphate. So there's our mole ratio. And now the last step is we need to use the molar mass of aluminum phosphate to find the theoretical yield for aluminum phosphate. You have 121.95 grams divided by 1 mole of aluminum phosphate. This is grams of aluminum phosphate as well. So we get that our theoretical yield is 24.845 grams of aluminum phosphate. And I'll put a little note here, this is the theoretical yield. Now we need to calculate the percent yield, that's what it's actually asking for. So we're going to place our actual yield first, 19.6 grams of aluminum phosphate, divided by 24.845 grams of aluminum phosphate. And we will multiply this by 100, and we find that our percent yield is 78.9% percent yield of aluminum phosphate. So let's say there was one lab group who had this percent yield. They had the 78.9%. So now I've added in this next problem. It's not included in your worksheet that goes along with this tutorial, but I wanted to show you how to do this since it is going to be seen on the homework. So let's say there was this other group, and this other group had a percent yield that was a little bit better than the first group that we saw. Their percent yield was 86.7%. And so given what we know about the reaction, we want to know what was the amount of aluminum phosphate produced in lab for this group. And so when we see this aluminum phosphate that's produced in lab, we know that we're looking for our actual yield. That is what we want to find. And so given our equation, actual yield divided by theoretical multiplied by 100 equals our percent, we should be able to plug in some of these values that we've been given and solve for the actual yield. So this times by 100 is not affected, but we're looking for the actual yield, and we know our theoretical yield, we've calculated that previously, so our theoretical yield does not change. It is 24.845 grams. So now we need to solve. And so to solve for this one, first I'm going to start by removing the 24.5 grams from the denominator by multiplying both sides by 24.845. And then to solve for the actual yield, I am going to divide by 100. So now that I've solved for actual yield, I will get that my actual yield is equal to 86.7 multiplied by 24.85 divided by 100, and this is 21.5 grams of aluminum phosphate. That is our actual yield. So that just gives the percent yield problem just a bit of a different look. If you're still using that formula to solve for something pertaining to percent yield, given this percentage here, but we're looking for a different variable, and so you have to solve for this variable by rearranging the equation, and then we get that our actual yield would have been 21.5 grams. So that is the end of this tutorial. Please stay tuned for the next one, which will be solving for multi-step problems.